All right, good morning. All right, we are looking at a question on moment of inertia. And before we solve this question, let's do a flashback to last week. I was saying that moment of inertia is given as I equal to summation of the product of the mass and the distance between particles. All right, so m is the mass of each particle, and the r is the distance about the axis of rotation. All right, with these we can solve questions regarding moment of inertia. Now, moment of inertia is also related to the radius of gyration. So moment of inertia is related of inertia is related to radius of gyration, and the symbol for this is K. So the moment of inertia and radius of gyration are related by the formula I, moment of inertia, equal to mass of the body times radius of gyration squared. With this formula, we can solve for radius of gyration. As you all know, m is the mass of the body. All right, now let's look at the question. It says 4-point masses 1 kg, 2 kg, 3 kg, and 4 kg are located at the corners A, B, C, and D of a square of sides 1 meter. So this is a square of sides. Right? It is A, B, C, and D. Right? And each side is 1 meter, as you can see. Right? Each point of mass has 1 kg. So at point A is 1 kg. At point B is 2 kg. At point C is 3 kg. At point D is 4 kg. Alright guys. Now it says find the moment of inertia and radius of gyration in each of the following cases when the axis of rotation is A, passing through A and perpendicular to A, B, C, and D. Now, how do we solve this? All right. Now, for the first question, it says passing through A and perpendicular to the plane A, B, C, and D. Now, how do we solve this? If you don't mind, I can withdraw the question. So this is the square point A, point B, C, and D. And at this time, the axis of rotation is at point A, right? And we are asked to find the moments of inertia when the axis of rotation is at A, right? So before we solve this, we draw a table. We draw a table. Draw a small table. This is the mass in kg. This will be my radius from the axis of rotation is in meters. All right, and here is my masses: mass A, mass B, C, and D. Now, the mass at point A is 1 kg. Mass at point A is 1, at point B is 2, at point C is 3, at point D is 4. And the radius from now the radius at point A is 0 because the axis of rotation is at A, right? Now at point B, the radius at point B, as you can see from the diagram, is from B to A is 1, right? Because each side is 1 meter. So at point B to A is 1. Is 1, right? Next is to find the distance from point C to A. Now is to find the distance from point C to A, from point C to A. Let's find the radius at point C. As you all know, the sides of the square is 1 meter and 1 meter. So we need to find the distance from point C to A. Now I can redraw this diagram. Becomes this is 1 meter, 1 meter. This is RC. Now what is the distance at this point or at this length? Now what is the distance from point C to A? We can solve this using Pythagoras Theorem. it says that the hypotenuse squared, which is RC, is equal to the opposite squared, which is 1, plus the adjacent squared, which is 1. So we now have L squared equal to 1 plus 1. That becomes RC squared equal to 2. So we now have RC squared equal to root 2. So RC equal to root 2. So the distance from point C to A is root 2. So the distance at C to A is root 2. Alright. Next, the distance from points D to A, as you can see, is 1 meter. So that's 1 meters. Alright. Now we input these values into the formula. So what was the formula? The formula is moment of inertia is equal to summation of the masses times the radius squared. This becomes mass of A times RA squared plus the mass of B times RB squared plus the mass of C times RC squared plus the mass of D times RD squared. Now we log in the values. The mass at A is 1 times radius at A is 0 plus the mass at B is 2 times the radius at B is 1 squared plus the mass at C is 3 times the radius at C is root 2 squared plus the mass at D is 4 times the radius at D is 1 squared. Alright, so what next? We begin to evaluate. So we have this is gone to 0. Alright, so we now have 0 plus 2 times 1 squared is 2 plus 3 times root 2 squared. Root 2 squared gives us 2, so it becomes 3 times 2. That gives us 6 plus 4 times root 4 times 1 squared is 4. So my moment of inertia is equal to 0 plus 2 plus 6, 8 plus 4 is 12 kilogram meters squared. That is my moment of inertia at point A. Also, we are asked to find the radius of gyration at point A. And the formula is I equal to mk squared. Alright, now our moment of inertia is given us as 12. The mass is given as mass of A plus mass of B plus the mass at C plus the mass at D. So that gives us 1 plus 2 plus 3 plus 4, and our masses is 10 kilogram. Now I know my total mass, I know my moment of inertia, so I can find my K. So we now have So I can transpose this. We can transpose this. So we have k squared. We have k squared. So we transpose this, and we have k squared equal to moment of inertia over the mass, over the total mass, which gives us 12 kg meter squared over 10 kg. So my k squared equal to 1.2 meter squared. So my k becomes root 1.2. Alright, 1.2. So that gives us 1.1 meters. Alright, so that is the moments of inertia at point A and the radius of gyration at point A. So if you don't mind, A, subscript A, alright, this can be subscript A. Alright, so this is the moment of inertia at point A and the radius of gyration at point A. Alright guys, so next we are finding the moment of inertia passing through the center of the square and perpendicular to plane of A, B, C, and D. Now, as you all know, this is the square, and this is point A, point B, point C, point D, and each side is 1 meter, 1 meter, 1 meter, 1 meter. Now we're asked to find the moment of inertia if the axis of rotation is at the center. Alright? Alright, that means we have to find the distance from point A to the center, from point B to the center, from point D to the center, and from point C to the center. Right? As you can see, the distance from point A to the center, from B to the center, C to the center, and D to the center must be the same because it is a square. So how do we get the distance from point C to the center, or for point B to the center? So I was saying, whatever you get from point C to the center will be the same for point D to the center, for A to the center, and B to the center. So if you don't mind, I can draw another diagram to find the distance to the center. You can draw another diagram here. Alright, this is point D, point C, and this is the center O. Now, as you all know, we're looking for this distance, so I can cut it off. So this was 1 meter, so when it becomes half and half. Alright, now from year to year is 1 meter, so from here, see, from this point to this point is 1 meter, so from the center to this plane will be half, so this is half. So now I can find the distance from point D to the center, or 4 point C to the center, and it is the same. So if you don't mind, let's find this at RD. So I can also solve this using Pythagoras Theorem. So that becomes hypotenuse squared, which is RD squared, equal to hypotenuse squared, which is half squared, plus adjacent squared, half squared. Alright, so we now have 1 over 4 plus 1 over 4 RD squared. Alright, so when you solve this two, we got 1 over 2. Alright, so what next? We take the square of both sides, becomes RD equal to square root of 1 over 2, which is the same as saying root 1 over root 2. And guys, please note that in math, root 1 is same as 1 over root 2. Now we can solve this by rationalizing. Alright, so when we rationalize 1 over root 2, we get this becomes 1 over root 2 times root 2 over root 2. So my RD becomes root 2 over 2 meters. Right? So the distance from D to center and from A to the center is root 2 over 2. So I can say RD equal to RC equal to RA equal to RB is what? Root 2 over 2 meters. So the distance from D to the center, from C to the center, from A to the center, and from B to the center is root 2 over 2. Now we can solve the question. We draw a table again. This is my masses in kg. This is my distance from the center in meters. Alright, so this is point A, point B, C, and D. Now as you can see, the mass at point A is 1, at point B is 2, point C is 3, point D is 4. The radius from the center for each point is the same, which is root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. Alright, so now we can now log these values into the formula. So the moment of inertia at the center is mass of A times RA plus squared plus mass of B times RB squared plus mass at C times RC squared plus mass at D times RD squared. That becomes mass at A is 1 times RA root 2 over 2 or squared plus mass at D is 2 times root 2 over 2 squared plus mass at C is 3 times root 2 over 2 squared plus the mass at D is 4 times root 2 over 2 all squared. Alright, now if you don't mind, you can bring that to your calculators. So here we have 1 times. Now root 2 over 2 all squared gives us 0.5 plus 2. Root 2 over 2 gives us 0.5 plus 3 times 0.5 plus 4 times 0.5. Now when we add everything up, our moment at point 0 or at the center is 2.5 kilogram meters squared. That is the moment of inertia at the center. Alright guys, alright, so next is to find the radius of gyration. At the center, right? And the formula is given as moment of inertia equal to the mass times k squared. Please remember that this mass is the total mass. Alright, now my moment of inertia at the center is given as 2.5, so we have 2.5 equal to the combined mass, which is given as 10 from this, is given as 10, so it's given as 10 times k squared. We transpose, we have k squared equal to 2.5 over 10. Alright, so k squared equal to 2.5 over 10 is 0.25. What next? We take the square roots of both sides. Alright, so what next? We take the square root of both sides. What next? We take the square roots of both sides. So that gives us k equal to 0.5 meters. Alright, so that is for the second question when finding the moment of inertia and the radius of gyration passing through the center. Alright, now for question C, we are asked to find the moment of inertia and the radius of gyration if it is along the side AB. Now in this case, the axis of rotation is on AB. As you know, this is the square, point A, point B, point C, and point D. And now we are asked to find the moment of inertia if the axis of rotation is at AB. So is at AB. So we are asked to find the moment of inertia if the axis of rotation is at AB. That means this point that means AB is rotating. Alright? In this case, my distance at A and B is 0. Alright? And if you recall, the distance of the square is 1 meters, 1 meters, and 1 meters, and 1 meters. For this question, this line is rotating. Alright? So step 1, I draw my table. As you can see, this is my mass in kg. This is my radius in meters. Right? My point A, my point B, my point C, and my point D. Now the masses at point A from the question is 1, point B is 2, point C is 3, point 4, point D is 4. These were the masses that were given to us, and the combined mass here is 10 kg. Now the distance from A is 0. Now because A and B are the point of rotation, the distances there are 0. I repeat that because the point because A and B are the point of rotations, so RA and RB is 0. Now for point C to line AB, as you can see, is 1 meters. From point C to AB is 1 meters. From point D to the line AB is 1 meters. Point D to AB, as you can see, is 1 meters. Now I've gotten my values. So next is to find the moment of inertia at AB, which becomes the mass at point A times the distance from A whole squared plus the mass at B times the distance from B whole squared plus the mass at C times the distance from C whole squared plus the mass at D times the distance at D whole squared. Now we log in the values. Mass at A is 1 times the distance from A, which is 0 or squared, plus mass of B is 1, RB is 0, plus the mass at C is 3, RC is 1 or squared, plus mass at D is 4 times RD is 1 or squared. So as you can see, this is 0, this is 0, so we have 0 plus 0 plus 3 times 1 squared is 3 plus 4 times 1 squared is 4. So my moment of inertia at AB is 7 kilogram meters squared. Now we can find the radius of gyration along AB. Alright, so moment of inertia at AB equal to the total mass times the radius of gyration squared. Now the moment of inertia at AB is given as 7 kilogram meter squared. So we have 7 equal to the mass, which is 10 times radius of gyration. So we transpose, we have radius of gyration equal to 7 over 10, right? So that becomes radius of gyration equal to 0.7. All right, so we have radius of gyration at AB is equal to the square root of 0.7. So my radius of gyration at AB is giving us 0.837 meters. So that is my moment of inertia along side AB and the radius of gyration alongside AB. Now for the last question, which is D, we are asked to find the moment of inertia and the radius of gyration along the diagonal AC. Okay, I want you guys to do this yourself. If you have any question, feel free to send me a message or leave a comment below. Thank you very much. So do this. Thank you for listening. Bye bye.